Alaksa Communications Systems has launched one of the nation's most significant telecommunications infrastructure projects in the last decade. It's called the Alaska-Oregon Network, or ACORN, and it's a new high-speed, high-performance fiber optic cable system that will greatly enhance bandwidth capacity and security between Alaska and the rest of the world. With demand for bandwidth growing at average rates of 40% a year, this project is vital to fueling the state's economy and to meeting the expanding needs of our customers. This is especially true for large commercial and government clients who need fast and reliable ways to transmit and store vast amounts of data.
Everybody wants more bandwidth, from the individual home users to businesses especially. And as businesses become more global, they're more diverse, spread out geographically, they need to have each of their different offices interconnected. And the businesses in Alaska, from government to the university to hospitals to all the large businesses up here, banking, they all have needs for a lot of bandwidth to stay connected.
In July, ACS's main supplier, Tyco Telecommunications, brought its cable ship Resolute to Homer, Alaska, to begin installing the cable undersea. Homer is located on the tip of the Kenai Peninsula, about a 4-hour drive south of Anchorage. On board the Resolute, coiled in the ship's belly, were some 3,000 kilometers of state-of-the-art fiber optic cable. The ACORN cable contains 4 fiber pairs, more than any of the existing cables in Alaska, enabling it to move data at incredibly fast speeds. Using the newest technology available, the ACORN cable can move 2.6 terabits of information per second. By way of example, that's the equivalent of downloading 320 sets of the Encyclopedia Britannica per second, or 35 feature-length movies, or more than 457 CDs every second.
Individual strands of fiber optic glass, thin as a human hair, and those laser transmission equipment that's at each end at the cable station in Homer and also in Florence, Oregon, will transmit information via laser light across that glass, and it will be repeated as it goes. There's repeaters that are built into the system that will lay on the bottom of the ocean and operate electrically for 25 years for the life of the system.
On July 7th, the ship's crew began offloading the first 100 kilometers of cable to be barged up to Anchorage. Later that month, divers working off Point Woronzof began laying the cable on the floor of Cook Inlet down to Nikiski. From there, the cable travels overland to Homer. From a landing station in Homer, the cable goes back in the water and travels down through the Gulf of Alaska to Florence, Oregon, where it ties into existing global broadband networks in the lower 48. The cable is buried at greater depths than the other existing cables, to protect it from boat anchors, fishing gear, and other external threats. The cable is also positioned overland between Nikiski and Homer to avoid heavily fished areas. ACS worked extensively with Alaska and Oregon regulators and commercial fishermen to avoid sensitive areas for fish and wildlife.
We worked with the permitting authorities extensively, both in Oregon and Alaska, to find the optimum route with the least amount of impact to everybody. Our intent was to, A, protect the cable, but also have the least amount of impact to fishermen and any kind of environmental sensitivities. We work closely with Fish and Game here in Alaska to make sure that we install the cable according to timelines to prevent any kind of impact to juvenile salmon and herring, and also to bird migration up by Anchorage. All that was included in the permitting, and we complied with all those rules.
ACORN is the newest of Alaska's submarine fiber optic cables. Unlike the other 3, which follow the same route out of Anchorage and down Turnagain Arm, ACORN exits Anchorage via Point Woronzof. This unique route provides redundancy and reliability that large commercial and government clients require. In a place that's prone to earthquakes, avalanches, and other natural disasters, ACORN's route minimizes the risk of Alaska being cut off from the rest of the world in the event of a catastrophe. That's key to ensuring that business and government entities operate smoothly and without interruption.
In 1964, Alaska was struck with the strongest earthquake ever recorded in North American history. It registered 9.2 on the Richter scale. This project will help ensure that if a similar natural disaster occurs in the state, our clients' data needs will be much more securely protected.
ACORN is but one element of ACS's $175 million investment in fiber connectivity to the lower 48. Another piece is ACS's acquisition of Crest Communications, owner of one of the 3 existing fiber optic cables linking Alaska with the continental United States. With ownership of Crest, ACS has the most redundant fiber optic system in and out of Alaska, including several Alaska-based landing points: Whittier, Valdez, Lena Point and Juneau, as well as Anchorage. This integrated system connects with ACS's advanced in-state networks and will be monitored and controlled by 2 network operations centers, one in Alaska and one in the lower 48. No other Alaska carrier has a diverse set of network operations centers. With the prospect of a $30 billion natural gas pipeline project coming to Alaska, the need for reliable and fast bandwidth will only increase. Speed matters in today's increasingly computer-dependent business environment. Industries as diverse as healthcare, banks, and security need reliable, high-speed connections for everything from telemedicine to e-commerce to interactive distance learning. The new Acorn Fiber investment puts ACS in a strong position to meet the growing needs of all of Alaska's businesses and public service agencies.